Now, molecules behave very differently because they don't have oppositely charged particles. They're actually molecules of discrete little packets of atoms, and they're held together with covalent bonds. Now, these molecules can be small, like water is just three little atoms, two hydrogen atoms and an oxygen, to giant. Paraffin wax is a huge compound of like hundreds of carbon atoms and hydrogen atoms bonded together. And so these different sizes of molecules are going to give us different properties. There's also some other stuff in here that can happen. So why does water hang out together as a liquid if it's just actually a whole bunch of individual little particles? And it is just a whole bunch of little individual particles, all these little molecules. Well, there are attractions between molecules. Those attractions are weaker in some things and stronger in others. Because the attractions between water molecules are actually fairly strong for its size, it tends to be a liquid at room temperature. CH4, which is a similarly sized molecule, has much weaker forces of attraction between other molecules, and so CH4 is actually methane gas. It's a gas at room temperature. There's a weak attraction between one molecule of methane and the next molecule of methane. So these guys are not really that excited about hanging out with each other, so they'll be moving all over. They're a gas, whereas water molecules will stick to each other a little bit better, and they'll be liquids at room temperatures. Larger molecules, because they have more mass, tend to move slower, and so that's going to usually make them liquids or solids at room temperature. Their forces of attractions are weak, but strong enough to hold those slow-moving molecules together. Like I said, water is a liquid at room temperature, and methane is a gas, and that has to do with these intramolecular forces of attraction. So, like I said, these are due to charge. Molecules are not charged, but they can have an imbalance of charge distribution. So, since the molecules are not charged, they tend to be liquids or gases because they don't have strong forces of attraction to hold them together. Um, but like I said, we can have an unequal distribution of charge. So, oxygen has lots and lots of protons in it. Hydrogen has one proton in it. So, when water molecules form, the oxygen is selfish and it actually pulls the electrons closer to its side. So, we end up with the electrons piled on this side, and that leaves these protons over here sort of exposed from hydrogen. And so, we get these little magnet like things. With a negative, partial negative on this side and a partial positive on this side. And so a whole bunch of water molecules stick together like little magnets because of that unequal charge distribution. Now, overall, the whole molecule is still neutral, but they are going to stick to each other. So, water is a liquid at room temperature because its forces of attraction are fairly strong for that small molecule. So polar molecules stick together like magnets. They also like ions because ions are charged, and so they can stick to ions as well. And so a polar molecule will have a higher melting and boiling point than a similar sized non-polar molecule. Like I said, methane gas has a very low boiling point because methane is actually very, very non-polar. The carbon atom um, doesn't really get to pull electrons because the hydrogen atoms are equally distributed all the way around it. And so if it pulled electrons closer this way, these electrons couldn't be pulled in closer. So all the electrons are actually going to repel a little bit out, and no side of this is going to have a partial charge. It's all going to be fairly equal. So methane, not polar. They don't stick together very well. Water is polar. They do stick together fairly well.